Welcome to Maths for E channel, a past question on integration from Sri A-level past paper. Using the substitution x equal to sine squared theta plus 3 for theta greater than or equal 0 and less than or equal pi by 4, evaluate integral limits 3 to 4, square root of x minus 3 over 5 minus x dx. Let's do the first part. The substitution given x equal to sine squared theta plus 3. So I just call the integration as I equal the limit 3 to 4, square root of x minus 3 over x 5 minus x dx. So I just find the function in terms of theta. So square root of x minus 3 divided by 5 minus x. So x is 2 sine squared theta plus 3 and then minus. Then 5, then minus 2 sine squared theta plus, that is minus. So 2 minus 2 sine squared theta, again minus 3. The 3 cancelled out the numerator. So what we have, so 2 sine squared theta. And the denominator, 5 minus 3 is 2. 2 minus 2 sine squared theta, I just took 2 out. So 1 minus sine squared theta and 2 cancelled out. Inside the square root sign, sine squared theta, cos squared theta, that is equal sine theta or cos theta, just positive sine theta or cos theta, not minus, which we have been given that theta is acute angle, therefore sine theta cos theta has to be positive. So we have changed the function into theta, sine theta or cos theta. That's done. Now let's change the limit. We know the limits of x, but we need to find the limits for theta because of substitution. X equal 3, 2 sine squared theta plus 3 equal 3. Take 3 the other side. 3 minus 3 is 0. So 2 sine squared theta equals 0, sine squared theta equals 0, sine theta equals 0. From that, theta equal theta equals 0. Right. Then upper limit, x equal 4, 2 sine squared theta plus 3 equal 4. Take 3 the other side. 4 minus 3 is 1. Those 2 sine squared theta equal 1, sine squared theta equal half, x sine theta equal 1 over root 2. From that, theta is pi by 4. So now we change the limits for theta as well. We found the limits for theta as well. So the function changed into theta function of theta. And then again, the limits change for limits found for theta. What left? The dx. We need to change the dx in terms of theta. 2 sine squared theta plus 3 equal x, because that's a substitution. So differentiate x with the respect to x, just dx. So this side, theta, 2, just keep 2, sine squared theta. Sine squared theta, the differential of sine squared theta, 2 sine theta. Then differentiation of sine theta, cos theta. So 2, we already had 2 times 2, 4, sine theta, cos theta, times d theta. So this is the dx. So we found dx in terms of theta as well. So everything we found, we could change I 0 to pi by 4 the limits, and the actual function sine theta cos theta, dx is 4 sine theta cos theta d theta. Cos theta cancel out. What we have, 4 sine squared theta. I purposely took 2 and leave the 2 sine squared theta inside, and the integration and the limits is 0 to pi by 4. Here on this side, left-hand side, is cos 2a equal cos squared a minus sine squared a. That is another trigonometry identity or property of trigonometry. Cos theta, we know the cos squared theta plus sine squared theta equal 1. Cos theta equal 1 minus sine squared theta. So cos squared 1 minus sine squared theta, another sine squared theta, 1 minus 2 sine squared theta. From that, 2 sine squared theta equal 1 minus cos 2a. Surely the students should know this straight without going through that. So 2 instead of 2 sine squared theta, that is 1 minus cos 2 theta, because sine squared theta is the power in the trigonometric function power. You can't do it integrate, so that we have to change it into multiple angle. So that we change it into cos 2a. Right, now integrate easy. So keep the 2 out. 1, integration of 1 with respect to theta is theta. So pi by 4 over 0, pi by 4 and 0 minus cos 2 theta is sine 2 theta divided by 2. That's integration of cos 2 theta, sine 2 theta over 2, and the limits. So if you could substitute the limits, 2 there, and pi by 4 minus 0 minus sine pi by theta is pi by 4, 2 theta equal pi by 2. Sine pi by 2 is 1. Sine 0 is 0. So sine pi by 2 is 1. So that is 1 over 2 minus 0. Then expand it. 2 times pi by 4 is pi by 2. 2 times half is 1. So that is the first part done. The second part, or next one, partial fraction. So using partial fraction and find integral of 1 over x minus 1, x minus 2 dx. So integrate, find the partial fraction and find the integration. Let's do that first. Right. I again, just call it I integral 1 over x minus 1, x minus 2. So we need to change it into a single quotient function. So using partial fraction method, 1 over 1 minus x, 1 over x minus 1, x minus 2, a over x minus 1 plus b over x minus 2. Right. You can do it, find the a and b in a format way. I just wanted to go straight, not wasting time on algebra. So simply to find a, what's the denominator a is x minus 1. So if x minus 1 is 0, is x equal 1. So what we do on the left-hand side, cover that x minus 1 and substitute the value of x equal 1 for x minus 2. So 1 over 1 minus 2. So 1 over 1 minus 2, 1 over minus 1, which is minus 1, a is minus 1. B, same method, same approach. B, so we need to make that the denominator 0, that is x equal 2. Then cover that x equal 2 on the left-hand side, substitute the value on the rest of it. So 1 over 2 minus 1. So 1 over 2 minus 1, 1 over 1, that is 1. So B, A and B found, minus 1, 1. So the integral of 1 over that, 1 over x minus 1, x minus 2, x minus 1 times x minus 2, dx equal, A is minus 1. So I just took minus 1, 1 over x minus 1 dx plus 1 over x minus 2 dx. We know this the differentiation of denominator is in the numerator, or the numerator equal to differentiation of denominator. Therefore, just simply the integral is log. So minus ln x minus 1 plus same thing for that ln x minus 2 plus c is the constant. So if you're rearranging it, ln x minus 2 minus ln x minus 1 plus c. That is the part, the first part, or the integral of, that part. Now, telling us, so let ft equal integral, the limits t to 3, upper limits t, lower limit 3, 1 over x minus 1, x minus 2 dx. So it is what it is, just simply ft. They call it just a function, and integral inside the integral of the same function as what we did already. But all you have to do just substitute or apply the limits. So in other words, you just find the value of c. Right, okay. ft is integral of this, then 3 to t, 1 over x minus x. We know the integral of 1 over x minus 1, x minus 2 from the first part. That's ln x minus 2 minus ln x minus 1. Because of we know the limits, we don't need to consider the c. So limits t 3. From that, you substitute t, ln t minus 2 minus ln t minus 1, then substitute 3. 3 minus 2 is 1. So ln minus ln 1, minus minus plus ln 3 minus 1 is 2, ln 2. Then ft, this is actual ft equal ln t minus 2 minus ln t minus 1 plus ln 2. But what we left that ln 1. ln 1 is the logarithmic property. ln 1 is equal 0. You can, surely people know about it. If you could say that e to the power of z 1, you can write it e to the power of 0. Therefore, 0 times ln e is equal to 0. So, yeah, it's just, we don't need to know about it. ln 1, log 1 is, any log 1 is 0. Right, that's done. ft, we have found ft, the function or function of t. Okay, next one. Right, this function of t, we found out they ask you to prove that ln t minus 2 minus ln t minus 1 plus ln 2. So if you look at it, that's simply when you put the limits in, for the limits, the c become ln 2. So we don't need to go into that, right? Right, next part, using integration by parts, find integral ln s x minus k dx. K is real constant. So let's do that first. Right, okay. So it's again integral ln x minus k. But they want to use the by parts. So I just introduced, by parts mean the two function. I introduced one here. Always if it's ln function, so the log function or ln function, you must take that as u in that integration by parts format. So u is ln x minus k. If you differentiate that, d equal 1, because we will use it later, 1 over x, so log is 1 over x minus k, integral of x minus k, sorry, differentiation of x minus k is 1, so dx. And 1, dv is 1, dv equal 1. If you integrate both sides, v equal x. That's this one. So this u, this v, we know that. Now, the integration by parts, the formula says v times u. V times or u times v, whichever way you want to call it. So I'll put x first, x times ln x minus k. This is because of the log there, so I just put the x before. So v times u minus v times the differentiation of u. So v is x. Differentiation u, we found it here, 1 over x minus k dx. Simple. The first part is same, x times ln x minus k minus x over x minus k. We have integral x over x minus k. I purposely subtract k and add k. So I just no change, but purposely to eliminate that denominator. And eliminate the x over that. So the linear over linear and trying to make it, trying to simplify it to integrate. So minus k plus k. So just subtract k and add k. So no change made. So x minus k plus k. X minus k over x minus k, you could take it. That gives us 1. Then k over x minus k. So if you look at the next line, if you look at it, so it's sort of jump one line. Same as x ln x minus k, that's same. But here, as I said, integral 1 first. Integral 1, so that is here 1. Here 1. Because x minus k over x minus k is 1. Minus k, I just took k out. So what we have? 1 over k minus x minus k. So the first part is still the same, x times ln x minus k, and integral of 1 is x, that is minus x, minus integral of 1 over x minus k is log x minus k. You should know that's a differentiation of the denominator is numerator, therefore ln x minus k plus c, again c constant, constant. Right. Simplified, here we have ln x minus k, another ln x minus k. If I take that out, what we have x minus k, that and that, x minus k. So x minus k times ln x minus k. Then we have x minus x there, minus x, and plus c. So that is, what is it, integral of parts, integrate by parts, done. That's done. Right, next part. Lots of integrations. Right, next one. Hence, find integral ft. So ft, we know that. We found it already. Right, this is ft. This one, ft. So they won't integrate that. So just left-hand side, ft, the integral of ft, the right-hand side, whatever function we have on the right-hand side. The integral of log n, ln t minus 2 dt minus ln t minus 1, integral of ln t minus 1 dt, and plus ln 2 dt. It's all this whole thing. Then integrate. So simply, there's ln, we have done it. There's this type of thing, we have done it here. This integrate by parts. That's already done. So this is the answer we got. So therefore, all it is, the first part, x here is t. So x equal t, and k equal 2. So simply, that's if you could use this one, integrate the first one. X minus 2, x minus k, that is t minus 2, which said it, yeah, and ln t minus 2, because x minus k, to ln t minus 2, minus x is minus t. Right, that's part, that done. And the second one, this is x equal t, k equal 2. And here, x equal t, k equal 1. Right, for that, we have a minus there, so it's minus t minus 1. Instead of t minus 2, t minus 1, ln t minus 1. Again, another minus t, that become plus t, minus minus plus t. Plus, if you differentiate ln, it's a constant. So it just, in other words, is 1 here. So ln, 1, integration of 1 is t, with respect to t is t. So t ln, and c is a big constant, right? Okay, now here minus t plus t cancelled out. So what we have, t minus 2 ln t minus 2 minus t minus 1 ln t minus 1 t ln 2 plus 0. That is integral of ft. That is done. Okay, that part. So now move to C. The formula integral of a to b fx equal integral a to b fa plus b minus x dx. So what they're saying, integral of fx with the particular limits a and b, and if the same limits, but the x here is a plus b minus x. So it's fx, and this side, right-hand side, a plus b minus x. So instead of x, but the limits are the same. So that is equal. So if it's given some fx, then we can find that is equal integral of a plus b minus x format dx. That is given. A and b constant. Right. So for that, if that's given formula, a and b constant, show that integral of minus pi to plus pi cos squared x over 1 plus e to the power x dx. So that is the function given. Equal is this. So in other words, we need to prove that cos squared x over 1 plus e to the x dx equal the fa plus b minus x. If we substitute that, we should end up with integral of minus pi for same integration, but we should end up with e to the power x cos squared x over 1. So in other words, just say e to the power x included. E to the power x or squared x plus 1 over 1 plus e to the power x. So we need to prove it with the given formula, right? With the help of a given formula. So cos, that's the starting point. Let's cos squared x over 1 plus e to the power x. All right. Here, this is given. Given. So we're going to use it. Fx is, just purposely using it, fx is minus pi plus pi fx. That is fx, what fx is. The same, the limit is same, minus pi plus pi. And cos squared x is plus cos squared x over 1 plus e to the power x dx. So that is the fx. What we know that the integration of fx equal integration of f a plus b minus pi. Another lower limits, upper plus upper limits, minus x. Right. So what we need to do, just substitute that value. So here, a equal minus, is it a? Yeah, minus pi. B equal plus pi. So a plus b equal 0. That's what he, here I'll just put it minus pi plus pi. If just substitute the value, which is a plus b minus x. So minus pi plus pi cancelled out, just x. So integral of minus pi to plus pi f minus x. So it's just minus x. If it's fx, it's f minus x. We proved it. So if you could substitute that minus x for x in that given function cos squared over 1 plus e to the x, then we are in the right way, and then we have to prove it. So that is equal integral minus pi to pi, that's the limit, and cos squared minus x. So just all I'm doing, just this is the right hand side given formula. So minus. So instead of x, we just substitute minus x. So cos squared minus x plus e to the power minus x, because of its plus x minus x. Now it's x replaced by. So we know cos minus x equal cos x. Therefore, cos squared minus x equal cos squared x. So that is what I have it here. Right, so it's cos squared minus x is cos squared x, simply. And 1 plus e to the power minus x, e power minus x. What I did here is just simply multiply e to the power x nominator and denominator. So in other words, e to the power x, e to the power x is 1, isn't it? So instead of 1, I put e to the purposely put e to the power, because of we know in our proof we have an additional e to the power x. So that is, I'm trying to aim at that. So, right, okay. So just top and bottom, e to the power x. So e to the power x there. So what we have, e to the power x, cos squared x. But if you do this here, e to the power x, if you multiply 1 plus e to the power minus x, so if we e to the power x, 1 plus e to the power minus x, that is equal e to the power x plus e to the power x plus minus x. So that is e to the power x plus e to the power 0. That plus 1 e to the power x. That is exactly output here. So done. Job done. That's what they ask us to prove, e to the power x. So the integral of cos squared over 1 plus e to the power x, the same, put it this one, pi and pi. Yeah, and x squared. That's this particular limits. If the limits different, it's different. So e to the power x cos squared x over 1 plus x squared. Only the formula is given is fx with the limits fx equal the limits a b f a plus b minus x. So okay, that's done. What else? Yeah. Okay, and hence last bit. Hence, find the value of cost. So it's value. There's fx is given. Find the value of that. So you just substitute the limits and find the value. So value of that integral of the limits minus pi to pi cos squared x over 1. So fx, but we know the fx equal the other side, the right hand side, e to the power x cos. You could use that because the integration is that, right. Okay, it's here. I just wrote it again because we just proved it. So the left-hand side, we need to find the value. Before that, we need to get to the bottom of the integration because we haven't integrated yet. We know that the integral of this equal integral of that, the left-hand side, right-hand side, but we need to integrate and substitute the value, the limits, sorry, no value, limits, and then find the actual value. So this side, left-hand side, is this equal? This is, we know that we have been given this, or we have proved with the given formula. So this is what I did actually. I just add the fx function, the left-hand side, both sides. I'll tell you why. Because of it's trying to get rid of that 1 plus e to the power x. That's the whole idea. So to make it twice this one, so in other words, if I add the left-hand side one more, so that become 2. But this side, I just add the function. This is integral of cos squared x 1 plus e to x. So this is, and this one. So it's the same now, but it's twice. So if we could look at it, the limits are same, the denominator same, so just we can combine it, get it under one integral sign. So LCM is 1 plus e to the power x. Here is the denominator e to the power 1 plus e to the power x. Therefore, we can add that the top. So top one, cos squared x common out. So 1 on here 1, and e to the power x on this from this. So 1 plus e to the power x cos squared x. The denominator e to the power x, so we can cancel out. So what we have now, just the integral minus pi to pi cos squared x simplified. Right, cos squared x we can't integrate, so we need to make it into the multiple function. We know is, again, students should know about it, cos squared x equal half time 1 plus cos 2x. So instead of cos squared x, we're going to substitute that this one. Half outside the integral sign, integral minus pi to pi, 1 plus cos 2x, simply integrate. So 1, integration of 1 is x, integration of cos 2x, sin 2x over 2, and the limit pi minus pi. Half is there, half, and upper limit pi plus sine 2x, so sine 2 pi over 2, minus minus. So minus pi, minus inside the minus, and minus sine, or minus time plus is minus, sine minus 2 pi, because it's minus 2 pi 2. Here pi is another pi there, minus plus another pi there, so 2 pi. Sine 2 pi is 0. This is 0. And this one, 0 too. Because the sine 2 pi is minus sine 2 pi. Sine 2 pi is 0, so the whole thing is 0. So just all we have, the 2. So half time 2 pi is pi. But that is twice as much as what we need to prove. So this is, we could call it 2i. We need to find i. So 2i equal pi. So I equal pi by 2. It's a long, multiple different integration, quite a lengthy question. Thank you. Please subscribe the channel and share these contents with your friends and students. Thank you.